this video we will learn how to do an hypothesis test for two quantitative variables. In that case we don't compare means. We calculate the association of these quantitative variables through correlation. We have two kinds of correlations according to if our variables are normal or not. In the table we can see that we have the Pearson correlation if our variables are normal, and if instead of we have the Spearman correlation. Then the first thing that we have to do is to prove the normality, as we did in the third computer lab. If we read the exercise 5, it says that study the relationship between blood pressure and cholesterol at the beginning of the study. Then we go to SPSS in order to prove the normality of these variables. When we are in SPSS, we go to Analyze, Descriptive Statistics, and Explore. Here in Dependent List we put our quantitative variables that in the case are cholesterol at the start of the beginning of the study, and also blood pressure. We have to select in plots, normality plots, continue, and in that case we only see the plots. It's not necessary to obtain the statistics, and finally OK. In that case we have more than 50 observations. For this reason we use Kolmogorov-Smirnov, as I said in the third computer lab, and we observe that the cholesterol at the start of the study, its p-value is higher than 0.05. For this reason we can assume that the cholesterol level is normal, but the blood pressure, it has a p-value equal to smaller than 0.01, also smaller than 0.05. For this reason we cannot assume that the blood pressure is normal. For this reason we cannot use the Pearson correlation because one of them is not normal. For this reason we have to use the Spearman correlation. How we can calculate the Spearman correlation? We have to go in Analyze, then in correlate, bivariate. Here we have to put our variables. In that case are cholesterol at the start of the study and blood pressure. Here we have to select our kind of correlation. In that case it's not Pearson, but if we obtain that both variables are normality, we have to select Pearson. In that case we select Spearman because blood pressure has an p-value smaller than 0.05. For this reason I select Spearman, and finally we have to press in OK. At the end of the outputs we have the table of correlations, and in that case we have the correlation of cholesterol and blood pressure is equal to minus 0.019, and the p-value is equal to 0.369. For this reason I obtain a p-value higher than 0.05. For this reason I don't have enough evidences to reject the null hypothesis. Then the correlation is equal to 0. If I take a quick look of the example, we have two quantitative variables. Normality test reject the normality because blood pressure is not normal. For this reason we use Spearman correlation. We get a Spearman correlation equal to minus 0.019 and a p-value equal to 0.369. There is no linear association between cholesterol and blood pressure.